Welcome back for the lecture series on bioenergy. So, today we are on the third lecture. So, in the first two lectures, I gave an overview about the significance of energy in the global economy. We talked about the different forms of energy which are available and the energy economics, how it governs the per capita consumption and the standard of living, and how that rules the economic status of a country, whether we are underdeveloped nation or we are developed nation or we are developing nation, like and so on and so forth. Then we have enumerated about the different forms of energy consumption, where we talked about the commercial, industrial, residential and the transportation, where all the energy is being consumed. And apart from it, we have talked about how Indian economy can be more energy independent economy if we could exploit our bioenergy well. So, today in the third lecture, we will leap forward and there will be two segments what I will be covering. In the very first segment, we will talk about the different units of energy. In a sense, whenever we talk about energy, as we have already talked about, we talked about electrical energy, we talked about heat energy, we talked about nuclear energy and so on and so forth. But each one of these has to have a quantification. How I say this much energy is needed. Say for example, I say from here to go to some X place, you need to consume this much petroleum or this much gas or this much diesel or this much coal or something. Now, there has to be an equivalent unit. Say for example, I say in the heat energy. So, what will be the equivalent energy in terms of say thermal or electrical, or if I consume something in electricity, I should be able to convert it into how much thermal equivalent it will be there, like so on and so forth. So, today what we will do in the first segment, we will talk about the units of energy consumption. So, let us get back into the slides. So, today we are into lecture 3. So, part 1 will be units of energy. So, in other words, we will be dealing with the energy currency, how we equate energy currency of different forms of energy. Okay. So, and in the second segment, what we will be doing, we will be talking about the basic fundamental concept of bioenergy. So, if this is part 1, today we will be dealing with A. So, there will be part B, which will have a formal introduction of bioenergy. Okay. So, let us move on to talk about the units of energy, part 1. And the major units of energy, which is called the SI unit of energy. SI unit is standard international unit, SI unit of energy and work is joule, okay, in the name of James Joule. This was, and it is represented as J. Now, there is another unit which is very commonly used, which is also called British Thermal Unit or BTU. Energy is usually expressed in BTU, which is also called British Thermal unit. Now, having said this, that energy is expressed in terms of British thermal unit or in terms of joules, we have to have different equivalency. How much joules make 1 BTU, or how much BTU makes 1 joule, or how much kilowatt hour makes, say for example, you talk about electricity, just I was explaining. So, what is needed is, the next slide I will just kind of give you a feel. What we are looking forward to is something like this. Say for example, you have different forms of energy, say electrical, thermal, nuclear. So, these different kind of energy has to have different units equivalency. That is very critical in terms of whenever we are explaining any form of energy production or energy consumption, whether we are consuming electrical energy, we are consuming nuclear energy, we have to have a equivalency. So, let us talk about the equivalencies now. Okay. So, talking about the equivalencies now, so 1000 joules is equal to 1 BTU, British thermal unit, and these few tables are very essential for you people to kind of remember. That will help you to understand many things. 1000 joules, which is also equal to 1 kilojoule, because 1000 joules is equal to 1 kilojoule, okay, which is equal to 1 BTU. Fine. Similarly, there is another unit called 1 therm, THERM. 1 therm is equal to 100,000 BTU, unit 10, 100, 1000, 10,000, lakh. So, 1 lakh BTU is equal to 1 therm. So, that is the relationship between joules and BTU. Next from here we will move on to, and for you the reference what you can use to know a little bit more about it, will be US Energy Information Administration of the year 2008. Information Administration of 2008. Okay. So, this is the reference for from where am I am quoting all these things. Okay. Now, let us go for the other BTU conversion factors. BTU conversion factors. Now, BTU conversion factors, say for example, we talk about electricity. Generally, electricity is expressed in terms of watt. Okay. So, in terms of electricity, 1 kilowatt hour or 1 kWh is equal to 3412 BTU. So, you see this is the first instance where we are showing that how you can convert the amount of kilowatt hour in terms of British thermal unit. So, these conversions are very, very essential and it will come very handy. So, let us move on to the next conversion. After we have done this first conversion, let us talk about heating oil, okay? Because we heat oil for several purposes in the cars, in the aeroplane and wherever, okay? Say 1 gallon of heating oil is equal to 1,39,000 BTU. So, this is where the oil energy is converted into British thermal unit. Okay. Now, within that, if we talk about the diesel fuel, what is used in the diesel engine. So, 1 gallon of diesel is equal to 139,000 BTU. Okay. Now, if we talk about motor gasoline, which is used in most of the cars, so 1 gallon will be equal to 124,000 BTU. And similarly, for natural gas, which is used for cooking, one cubic feet of natural gas is equal to 1028 BTU. Okay. So, what is most important out here, the take home message out here is these conversion factors will come handy while one desire to compare the efficiency of different energy materials. So, this will come very, very handy when we will be talking about how we really can compare different forms of energies which are available to us. You might wonder why I have drawn this table for you, because one has to realize when we talk about bioenergy, we are burning biofuels or different form of bioenergy as we will be going through. So, one needs to equate that by burning say 1 liter or 1 gallon of biofuel or this much amount of it, how much thermal unit you are gaining, and one has to have a comparative value. Say for example, if X amount of say biomass, okay, X amount or say Y amount of biofuel, and what is their equivalency with respect to. So, there is a compared to compared to say X amount of oil, or how much electricity could be generated from these two sources, say for example. Okay. So, the economy works like this: if you need lesser amount of this to generate say Q amount of electricity at a cheaper price as compared to this one, then this one will be much more economical. So, it is all about how much conversion of how much would lead to usable power, or you can put it like this, something like a usable electricity out here. Whatsoever will be the usable electricity or usable power will dictate how much it takes to form that much of biomass or that much of biofuel or that much of say biodiesel or whatever we talk about. So, for everything there is an economic components which I am adding, because in the last part of the course this thing will come very handy. What is the economy of producing this much biomass or this much biofuel or this much say biodiesel, okay, or whatever This economy will be compared with the X amount of oil which we are consuming currently for all the things. So, once this comparison is in favor of all sorts of biological origin fuels or biomass and something, the economy will try to take a different kind of shift. So, that is why the conversion factor, I insist you people to kind of have at least try to remember few numbers very clearly, that this much oil, this many gallon of oil, this much will be produced, equivalent to this much thermal unit, this much kilowatt hour is equivalent to this much British thermal unit, like and so forth. It will be really helpful for any kind of, whenever you sit in a public forum or you talk to people or you listen to something, you should be able to calculate it immediately in your mind. Okay, if I use this, this is the benefit I have and this is the cost benefit ratio. So, there is this thing which will come very handy, as long as if you know these values, then you can build the what we call as the cost benefit ratio of energy economy. So, this will come very, very handy if you can instantaneously do that kind of conversion. So, having introduced you to all the different conversion tools or conversion factors, from here we will move on to the very, very core of this lecture series, which is the bioenergy and how everything falls in one spectrum. Okay, so, let us move on to the part 2 of it, of today's lecture, which is, so let us put the two words together, we call as bioenergy. Okay. So, if you look at these two words, so there are two different words here, one which is bio, if I split this word color, this is the bio, the other part is the energy. Now, whenever we talk anything about bio, we talk about something like some form of a renewable material. What does that mean? The plant grows, grasses grows, algal population grows, bacterial population grows. These are all of biological origin. Any life form which persists on earth, it grows. It grows because there is a perennial source of energy called the sun. We will talk about that as we will move through. So, when these renewable sources, so let us get the concept right. When these renewable sources are used to generate energy, we call that as a form of bioenergy. So, now what we are talking about is what are the different, first of all let us classify the different kind of materials of biological origin. Okay. So, those could be classified as renewable materials. So, something like this, get this concept in your brain, renewable materials originating from different life forms. Okay. And those are called biomass, and this biomass is used to harvest energy. Now, when you talk about this biomass, one of the critical question which comes is out here. How biomass is formed on planet Earth. We will deal with these questions just after this. So, this is a key question and we will be devoting lectures on this, how this biomass formation takes place. Just before that, let us take a look at, so let us talk about this part. Okay. So, let us talk about what are those renewable materials? And in the next slide we will go on and talk about what are those renewable materials of biological origin. So, that includes straws, plant straws, wood, animal waste, microbial waste, algae, algal mass or algal biomass, likewise and so on and so forth. There are series, I mean this list can go on, but these are some of them what we talked about. Now, next thing is that now these could be, there are two ways, two methodologies which could be followed. Either these could be how we can process them. They could be burned directly as solid biomass. Okay, this is one route. You all must have seen this, burned directly as solid fuel or biomass, and which leads to generation of heat or power. So, having said this part, when we are talking about you can burn them directly. So, this is an age-old process. If you look at it, people have burned wood for energy, for cooking, for heating the room and so on and so forth. Wood similarly, if you look at it, there is some very interesting thing about wood. So, wood has been used earlier, in a much earlier time, the wood has been used for traditional sources of not only traditional sources of fuel, but also of alcohol. We know that we can convert wood into alcohol. So, wood remained for a long till this date is one of the very traditional sources of alcohol and all these things. So, this is one way, or you have seen the animal waste or the cow waste, cow feces. You make these uplas and everything, which is kind of used for preparing food, like burning them, dry them up, and you can use the cow feces and buffalo feces and everything which could be used to develop the cakes which are used for burning. So, these are the direct conversion where a biomass is being converted directly for generation of heat energy which is used for cooking and other applications. Okay. This is a very age-old process. Apart from it, these biomass are being used for producing alcohol and several other products. This is one route. Okay. Now, we will come to a second route. Okay. The second route, talking about the second route, coming back, what we will be telling. So, from here what we can do, you can convert these ones, all these what you see out here, this whole thing could follow a different path, and I am coming to that path now. The second path is that you can generate liquid biofuels from all these, and there are different kind of conversion processes which are being followed, like pyrolysis and several other processes, biodiesel, bioethanol, where you are not directly using them, but you are converting them to much more energy efficient product which will generate more energy. Again the same thing, power and energy, and which could be used for one of the major things like transportation and all. Now, if you see, it is not that the bioenergy is something very new. The concept of bioenergy is as old as the evolving human race. Human being has been using different kind of, since the discovery of fire, human being has been burning biomass since ages for its most fundamental to the most complex requirements. But what is important to note here is that what is the current role. Instead of direct burning, as I have shown you out here, if you look through in the slide, if you look through, this is where, this is the traditional route. So, what we are telling is from this route, this is what is the dream. Why is it so? This dotted line what you see. Why we wanted to convert them more efficiently? Because the amount of energy which is generated by burning a log of wood as compared to by certain chemical process, if you could convert it in such a way that we generate sufficient amount of biodiesel or other product, then their combustibility, their energy efficiency is much more higher. This is where the whole role of coming back, this is where the whole thrust area of bioenergy stands. How we can convert these naturally available biomass into products of high combustibility, product of high utility and much more cleaner form of energy. So, keep this exclusively in mind. And now, I will add one more dimension to this. If you think of it, what has happened through the ages. Now, these biomass what we talk about, all these, say for example, we talk about straws, we talk about woods, we talk about animal waste, we talk about microbial waste, we talk about algal waste, like and so forth. Through the ages, under the earth, in high pressure, through ages, billions of years, under the earth, high heat, I am just showing in a triangle, pressure, we have converted to the product like coals and fuels. So, actually the nature has done this process over billions of years, the one which I showed you in pink. Now, what we really wanted to do, if nature has done it, and nature has done it at high pressure, lack of oxygen deep inside the earth. Now, if we know this process, say for example, now let's concentrate on the slide. If we know this process of conversion some way or other, if we know this whole process how nature has done it, okay, now could we, now here is the critical point to realize. If we know exactly this whole reaction has taken say 1 billion year or 1 million year or whatsoever, if you know the time and if you know the reaction, could we learn from nature and do those reactions in a controlled environment, which instead of taking billions of years could happen in few days. So, in other words, the other area of bioenergy is to learn those processes which nature does or nature has done over billions of years, nature has learned through it. So, the inspiration for the conversion of biomass, now let us coming back to the slide. So, the inspiration for all this conversion of biomass has to be drawn from here, has to be fit in here, and there where we believed we will be able to make a difference likewise. So, see for example, now there are three things, let me, because this is a very critical slide for you guys to understand. Let us again regurgitate it, what we talked about. So, we talk about the word called bioenergy, a biological component, a energy component. So, that means any biological material, could be a straw, could be cow dung, could be algal biomass, could be microbial biomass, could be plants, could be woods, whatsoever. If we could convert them or if we could use them for energy. So, the age old tradition remained, these have been burned directly using fire to generate energy, which is a direct conversion. There is another conversion which nature has followed through thousands and millions of years. What has happened? These things have gone down under the earth crust and are in high pressure, high temperature, lack of oxygen. They have got converted into what we today use or have been using for last 100 years as coal, petrol, likewise and so forth. Now then, what is the need? Nature has already done all these things. Why we needed to study bioenergy? So, here is the catch. Catch is this: if nature could convert by its high pressure, high temperature these products into something far more combustible. So, you can compare by burning a wood, driving a vehicle as compared to burning petrol will be much more easy using petrol. Why is it so? It's though the product, they have all originated from the same biomass, right. So, that is something very important to understand. It means nature has already discovered certain things through billions of years of its evolution, how to convert this biomass. What we are trying to learn is, we are getting inspiration of converting these biomass in a way so that we get more combustible product. Now, let us look at the slide. That is exactly what I was trying to highlight to you people. So, there are three parts what you can look at is, this is, one second, give me. So, this is your direct conversion route for traditional fuel usage. This is what nature has done, and this is where your generation will be heading. Okay? So, this is the basic concept of bioenergy which I wish that you people understand very clearly. Let me go back to the slide again. Here I told you that how biomass is formed on earth, because that is your raw material. So, if you do not know how the biomass is formed on earth, you will not be able to address this question what we are dealing, that how to deal with this kind of situation. So, for that, now our next slide we will talk about how the biomass formation takes place on the floor of earth. So, let us concentrate on it now. So, let us address the question, how biomass is formed on earth. This is the question which we will be answering now. Okay. Okay. Now, before answering this question, let us summarize what we have done as of now. We talked about, just I am keeping you on the loop, we talked about first of all the significance of energy, we talked about the different forms of energy, we talked about how the energy economy rules our planet and our livelihood and our standard of living. Then we talked about the different, how evolving concept of bioenergy could change the Indian economy. Then we talked about the different currencies, how energy can be calculated or how energy could be equated, whether it is electrical energy, whether it is a thermal energy like so on and so forth. And then we talked about the fundamental concept of bioenergy in terms of what are the biomass which are formed, how in nature they form over billions of years as coal and other products, how we directly burn them and how we could get inspiration from the formation of coal and everything to convert them into much more combustible product, and which is the core of it. And now we came to the question how biomass is formed on earth. So, this question we will be addressing in our next lecture, where we will be talking about the biomass formation on the floor of Earth. So, I will close in here and we will continue in our fourth lecture on how biomass is formed on Earth. Thank you.